Good evening. My name is Ravi Prakash and my roll number is 2K20 ME210. I am going to discuss about pneumatic systems in miscellaneous hydraulic machines. But before understanding pneumatic systems, let's talk about pneumatics. Pneumatics, the use of a gas flowing under pressure to transmit power from one location to another. So in this, a gas in a pneumatic system behaves like a spring since it is compressible. Or in other words, we can say that a pneumatic system is a system that uses compressed air to transmit the power. Usually, a centrally located compressor, it provides power to cylinders, rotary actuators, and other pneumatic devices through a system of tanks, pipes, and valves. The compressor sucks in air from the atmosphere, reduces its volume by compression, increasing its pressure, and then stores it in a high pressure tank. This compressed air can then be released to do work by acting on a piston or vane. So here is a general layout of a pneumatic system. First, the air is compressed in a compressor, and then it is stored in an air storage tanker, which is fitted along the compressor, and then it is passed to the moisture separator. In moisture separator, the moisture is removed, present in the air, and then it is passed through air filter. Now this air filter removes all the impurities like the dust particle which may obstruct the movement of the air, and then it is passed to a pressure regulator. The pressure regulator regulates the pressure, so it decides how much pressure that is to be actually supplied, and then it is passed through a lubricator, which lubricates the air, so that allows pass to air to pass through it smoothly, and then it is passed through air dryer. So and then using control valves, it is finally fed to actuator, and then finally the air leaves out. So here's the actual layout of a pneumatic system. So in this, the air is being passed through a compressor. It is being compressed, and then it is stored in a tank. And then moisture separator removes the moisture present in the air, and then passes through a certain number of valves, and then passing through pipe, it goes to finally goes to actuator and imparts the motion to the actuator, and then finally through other pipe it leaves, and this motion this all this controlled using air control valves. So here is the calculation of a fluid power in pneumatic systems. So using basic principles we can derive the power, fluid power or the pneumatic power. So as we know, power is work done upon time, which can be expressed in force into displacement, and then finally we get by substituting values and expressing the force as pressure into area, we finally get power as P into Q, where P is the pressure and Q is the flow rate. So P is P into Q. Now the P is pressure, which is force by area, which can be also written as W by A, where gamma is a specific weight. So gamma can be expressed as W by V, and then substituting the value of W, we get a gamma V by A, and then the pressure can be expressed as gamma into H. So the fluid power can also be expressed as P is equal to P into Q, which is P. Now we have calculated P as gamma H, so we substitute it, and we'll finally get P is equal to gamma QH. Now this pressure is in bar and Q is in liter per minute. Then fluid power can be expressed as P is equal to P into Q. Now expressing bar as in Newton per meter square, Newton per meter square, and liter per minute is 1 liter by minute, 1 minute. So 1 liter is 10 to the power minus 3 meter cube, and 1 minute is 60 seconds. So substituting that value and putting that in the formula, finally we get P is equal to P into Q by 600 in terms of kilowatt. So here P is in bar and Q is in liter per minute. Now we'll compare pneumatics versus hydraulic system. So what is the actual difference between these two? So a pneumatic system, in this air or gas is used for working of system, but in case of hydraulic system, fluid is used for working of system. Pneumatic produces less power, hydraulic produces more power. Pneumatic pressure is limited up to 10 bar pneumatic systems, whereas in hydraulic system pressure produces from 100 bar up to 700 bar or even more. In pneumatic system, working fluid available in cheap rate, but in case of hydraulic, it is fluid is costly as compared to pneumatic system. Pneumatic system, the process is clean, and in this process is not clean. It is easy to operate. System with high in hydraulic system with high pressure is difficult to operate. Pneumatic maintenance is easier and quicker, but in case of hydraulic, maintenance is not easier. Pneumatic system, a low initial and operating cost. Hydraulic system, higher initial and operating cost. So from this we can calculate that overall pneumatic system is good, but however they all have different uh, weaknesses. Now we'll discuss about benefits of pneumatic system. So first is speed and power. So whenever accuracy isn't vital and high forces aren't required to move the load, pneumatic systems are the preferred choices. Pneumatic systems are great for medium power applications where speed is needed and the absorption of force is beneficial. Second is convenience. Because pneumatics equipment requires less force and low pressures, tools can be made of lightweight materials which can make them easier to handle. Moreover, and transport if hydraulic power were to be used. They also had abundant source of operating gas on hand at all times, provided the system has the right filters in place to ensure the air is clean for use. Third is safety. Pneumatic systems remove the requirement for electricity at the point where the operative is working, reducing the risk of shock, sparks, and explosions. They can also release their working air gas like air into the atmosphere safely once it has been expended. Unlike hydraulic systems, which have to be completely scaled and therefore the potential leakage represents a risk. Maintenance. Pneumatic systems require little cleaning due to the pressurized air, usually forcing any dirt out of the system through everyday use. Maintenance is fairly straightforward. Replacement of filters is important, as well as lubrication of moving parts and ensuring seals are intact. Noise. Although air compressors can be quite noisy whilst they are running, they are silent when off, and the equipment when using compared air to function is usually relatively low in noise level compared to other options. So there are certain applications of pneumatic system. So they are present all around us in domestic application, healthcare settings, transportation, industrial plants. We took a look at some of the examples here, like in air brakes. So these air brakes used in trucks, buses, trains, thanks to their safety and reliability on heavy loads. So they are very helpful. And second is dental equipment. Whilst involved, unloved by most patients, the use of compressed air to power dental drills means that they are gentler than the otherwise might be, and the risk of shock and hazardous fluid leakage is removed. So they are using dentistry also. Construction applications like civil construction projects often require equipment such as jackhammers and road drills, both of which can be powered through pneumatics, allowing for remote working under just about any conditions. Automated production equipment. Using everything from assemblies to gantries, pneumatics equipment is a common component of the industrialized world of production, providing precise, quick, and safe solutions. Thank you.